All right, I know this isn't one of your favorites, but we're back to graphing. And again, we've learned quite a bit about equations and information that we can get from those equations. So let's get at it. Um, we are going to start graphing a projectile problems. The science class created a ball launcher that could accommodate a heavy ball. They moved the launcher to the roof of a 23-story building and launched an 8-pound shot put, 8.8-pound shot put straight up in the air. The motion described by the function is here, where h represents the height in feet and the shot put above the ground um, with respect to time in seconds. Graph the function, identify key features of the graph. So we're looking to see, obviously, where does it start, where does it reach its peak, and um, also when does it hit the ground. So we got a lot of things we can look at here. Let's take a quick look at what we got. I would factor out the 16 if it comes out evenly. Let's take a quick look. All right. So if we say 0 is equal to, and we factor out that negative 16, we get t squared minus 2t minus, and 16 goes into 240 um, 15 times. Um, and now we're looking for factors of 15, negative 15. That add up to negative 2. Probably going to be 3 and negative 5, right? So 0 equals negative 16. T plus 3 times t minus 5 tells us that t is equal to negative 3 and 5. Now, interestingly enough, we know the negative 3 here is not relevant because it's not going to um, go in negative time. So let's go ahead and plot the intercept. We're going to hit the ground right here. We also know that we've got an initial height when h is, or when t is 0, h is 240, right? So we can plot that right here. We know that the axis of symmetry, x is equal to negative b over 2a, so um, negative 32 over uh, negative 32, or positive 1. That means my vertex is at 1 comma something, and we're going to plug that in and see what we get when f of 1 is equal to negative 16 times 1 plus 32 times 1 plus 240. Those ones are somewhat irrelevant using your calculator. Um, Hopefully you'll end up with 256 feet. 256. So now I know that this, when x is 1, where's the 1? We're at 256 right here. This is symmetrical. That gives us 4 points. Um, and should be enough to sketch our graph. All right, it looks something like that. Okay, so now we can answer questions after how many seconds does the shot put hit the ground? 5 seconds. What is the maximum height of the shot put? 256 feet. What is the value of h of 0? And what does it mean for this problem? 240 feet, and that's the initial height. Um, of the shot put. All right, we're supposed to match the graph with the correct equation, and I'm going to let you stop the video and go through and do that. I will go ahead and give you the answers here in a minute. All right, so hopefully you got some of these correct. B was 5, and you can tell some of these are facing up, some of these are facing down. Vertex form or intercept form, I should say, um, the initial um, um, slope, if you will, should help us determine what graph is what. All right, what information did you use to match the graph's equation? That was just trying to decide, is it facing up, down? Do we know where the intercepts were? They all seem to be the same. And what was the A value is, what was the initial slope? Was what we were looking at for the most part. All right, solve the following equation. So notice that in problem 5, we're looking ahead. We're gonna graph this. So before we get going, let's go ahead and solve. All right, so with this solved, we can then move on to problem number 5, which again is going to ask you a whole bunch of questions about this. And remember, we've got -10 and 5 already as intercepts. So we already know that our vertex is right in between -10 and right in between -10 and 4. And I put that in the wrong place, didn't I? 4. So halfway between 10 and 4 is going to be 3. So I know I have a vertex, or I should say my axis of symmetry, right there at 3. That probably should be a little thinner, but that's okay. -3, comma, something. So these questions over here are just leading you through what I'm going to take you through. Now I know that my vertex, I can plug this in and say f of -3 is equal to, and I could plug things in. -3 squared is 9, minus 6 times -3 is -18, minus 40. So I end up with 27 minus 40 should be -13. And we can see the mistake because that was supposed to be plus, right? So that's going to be -9, and -40 is -49. -49. So we go down here to -49. We know that we're going to go up 1 over 1 both directions. So if we want to, the next point's literally going to be here and here. These are symmetrical, right? I know that I have a y-intercept at -40. That goes here. This is also symmetrical, so that's going to go there. I've already got 7 points plotted that were fairly easy to find. And that's what our graph looks like. And hopefully a lot of this stuff is making some sense. All right, so now we got 6 and 7. I'm going to have you stop the video and let you go through this. But again, you've not only got a graph, but they're asking for a lot of different stuff. So let's see what we can find based on the different equations. So I thought I'd stop here and show you what I've got. Notice that I started out obviously with the intercepts. I could find half the distance between these two gives me my axis of symmetry, which gives me my x value of my vertex. And now I've got to find the vertex and the y-intercepts, and that can simply be done by plugging in -1 and 0. And there I go again, writing down the wrong numbers. I did have it plotted correctly, but it should have been 2 and x equals 2. So let's do the work. Okay, so after plugging in 2 into this equation, I got 9. That gave me a vertex of 9. Using my leading coefficient there of -1, I go down 1 over 1 for those 2 points. If I plug in 0 for x, I get 5, and then the symmetrical point at 5. And now I've got a graph that looks something like this. All right. Notice that 7 is going to be another problem that's, this one's in standard form, so stop the video and give it a shot. All right, so hopefully this makes some sense. I started out by factoring and finding the x-intercepts. Then I found the axis of symmetry, right? When I knew the axis of symmetry, I could then find the vertex. The y-intercept was pretty easy, and you graph your function.